This week's topic is estimating and project costing. Let's get started. Estimating the cost of a project is a very important activity. The users want to know right up front how much is the system going to cost, and for good reason. Every company that works on a system is really investing in the system. They're really putting good money as an investment in the creation of the system to either reduce expenses or increase revenues, or hopefully both. They want that investment to pay off within the shortest period of time. Now, although the return on the investment, and we usually call that ROI, by the way, that return on the investment is typically somewhere between 18 months and 3 years for most systems, although the users usually like the shorter the better. So the difficult thing about producing an estimate is that you're trying to prepare an estimate when you know the absolute least amount about the system to be built. You got to remember that in the early days of any system, you're still trying to understand what the user wants, what will the design look like, how will the team perform, what will their skills be, what kind of technology will you use. So there's a lot of different things you need to consider. So it's a very important part of the process. Now, what determines the estimate is usually requirements. So what happens is each requirement will have a cost potentially for the end product. So we've gone ahead and we've talked about that as part of the vision document. We produce a list of functional and non-functional requirements. And most of the costs will be related to those functional requirements. So the first thing we need to be able to do is to estimate all of the user stories that are sitting in the product backlog. So the nice thing is that by estimating each one of those items, the user can assess for themselves whether it's a worthwhile effort to include that in the system. So not only will you be able to add them all up and find out the total cost of development, but a user will be able to make a well-informed decision based upon each and every requirement that they're asking you for. So you have to get used to doing this, and it is still an estimate though. It's not a guarantee as to the price, but you will have to get as close to that number as possible. One of the methodologies that I use and I really like is something called relative estimating. So let me give you a little bit of background first, and then we can talk about it specifically. So let's look at the skyline of Detroit. Looks great from Windsor. And in fact, if I look at those buildings on the right-hand side, you can actually look that there are two buildings side by side, and they're relatively the same size. So would it be fair to say that if you were told how much time and how much cost it would be to build the first building, would you be able to estimate the cost of the second building, both in terms of time and dollars? I think you could. So if the first building cost $1 million, then the second building would cost $1 million as well. So you've got a $2 million project. Conversely, now that you know the cost of the first two buildings, could you, through relative comparison, look at the third building now? So the third building is about the same width. It's almost double the height. And if all things being equal in terms of complexity, then you could probably estimate that that other building now would be worth $2 million to build. So you've got $1 million for the first, $1 million for the second, and $2 million for the third. And now you could actually move across this entire cityscape, comparing one building after the other. And by just doing simple comparisons, you could pretty much figure out what these buildings would cost. Without relative buildings for comparison, then how would you estimate that cost? If I didn't tell you that it was $1 million for that first building, could you have figured that out just simply by looking at it? Probably not. But by comparing a known value against others of similar size and complexity, you can typically have a pretty good estimate. And that's what this process is all about. So now that we know how long a project's going to take, by just simply looking at the product backlog, we can now create a baseline estimate that can be included in a vision document. So this is the basic math behind that. As I've mentioned, size and complexity are intertwined and have a relationship on the estimates that we generate. So we need to figure out then, just for comparison purposes, right from the beginning, what do we use as kind of a base for size? Well, I kind of look at it in terms of 4 hours being the base. So if it's something that I can do in a half a day, guess what? I call that a 1. If it takes me a full day, I call that a 2. So we have to assign some type of size value to it. So all things being equal, if things are easily understood, if something takes me a half a day, it's a 1. If it takes me typically a full day, then it's a 2. So let's look at this in terms of a real application. So let's say we're going to build a web application, and we've all done that before. We've always built an application that's got a home page, it's got a contact us page, a profile page, a whole bunch of other things. So let's start with the home page. Well, we need to think of it from a developer's perspective. We need to stand back and think of all the tasks that we do to create a home page. We need to design it. We need to code it. We need to get the images for it. We need to test it, make sure it works. We need to put buttons on it or navigational controls. So let's pretend that based upon my abilities and my previous experience, that it takes me about 8 hours to create a typical home page. That's fantastic. So now that we've established that a home page takes 8 hours to complete, I need to assign a number to it, and that's 2. Remembering that we don't put our estimates down in terms of number of hours, we put it down in terms of relative size. So let's say that the home page is a 2. Perfect. Well, relative to the home page then, how long would it take us to create a contact page? Well, to be honest, it's probably about half the effort. Because I've already figured out what the color scheme is going to be. I've already got the kind of the basic layout of the form designed. But I might have to create a map. I might have to get the phone numbers. I might have to use an API to drop a pin on the map based on our location, and I might put a link for driving directions. So that's something I could probably do in about, it's probably about half as complex as a home page. So that being said, I would go ahead and I would assign really a story point or a user story point of 1. So if I assigned a 2 to the home page and we call that a story point, then my contact us would be 1. You now have to go through the entire list of requirements in your product backlog, compare it to what you've already established as your baseline, so that kind of that home page, and then create really a story point and associate it with each one of those requirements. So the home page is 2, the contact us is 1. Now, I want to stop you there for a second. So let's assume for a moment that we're going to build a system that's only going to have a home page and a contact us page. Wouldn't that be a great system? Well, let's just pretend for a minute. So when we think about it, given that each unit is worth about 4 hours, a system of 2 pages would take about a day and a half to complete. And that would be one person working on it, due to the fact that the contact page would be half of the amount of time of the home page. And again, because the complexity also is very similar, great. We've got a 2 and a 1, which gives us 1.5 days. Well, unfortunately, when we have an application that's made up of many more pages, the number of pages will vary as well as their complexity. So when we think of complexity then, so the great thing is when we've assigned these first couple of story points, when we think about complexity, at least we have something for comparison. But what about complexity? What if we haven't done this before? What if we're building a page that's doing something new? What if we're building a mobile application that has a camera functionality and I want to access that, grab an image and store it to a server? That's where it gets a little bit more difficult. So, here's another thing with the numbers. When we're trying to create these estimates expressed as a story point, as mentioned, we're trying to use a unit of measure that's really detached from person hours. Okay? Although we might start out that way and thinking that something is, a 1 if it's a half day, it's still relative. Okay? And I'm going to talk about that in a couple of slides down. But one thing I want to introduce you to is this whole notion of using the Fibonacci sequence when actually assigning those story points in the beginning. This is something that's optional, but I've seen done very effectively with teams, and it's something that's very popular. So let's recognize what is the Fibonacci sequence first, and then how can it be used for creating story points as part of your estimates. Well, if you think of the Fibonacci sequence, if you start with the number 1, the next one in the sequence is a 2. And if you understand how the Fibonacci sequence works, you'd know that the next number is 3. So Fibonacci is really where you take the first two values, so a 1 and a 2, you add them together, and that becomes the third value. Well, how do you figure out the fourth value? Well, you add the second and the third, so a 2 and a 3 equal 5. How would I know the next value in the sequence? A 3 and a 5 would be an 8, an 8 and a 5 would be a 13, and so on. So we use this kind of slightly modified Fibonacci sequence. Well, what do we use it? What if, however, I'm looking at something, and again, where the requirements from both a business and technical perspective are easily understood, and I've got little or no research. But what if there's a few unknowns about it? What about using that camera? I've never really used it before. I mean, what API will I use? How well does it function? And in fact, it may even require some intermediate programming skills to do it rather than basic skills. You have to remember that we have to kind of plan this around, the lowest common denominator. And so really, if we've got a complexity of 1, then anybody should be able to do it. But when the complexity starts going up, we have to start factoring in a little bit of extra time to do the work. And in fact, we might actually double the time. So if the home page has some unknowns associated with it, a few of them, and because of what we're doing, it's going to be a little bit more complex, then again, we're going to probably double that estimate, and it won't be really a 1. Ultimately, we'll take this complexity factor, and we'll now make it a 2. So let me describe the process first, and then I'll go back to the Fibonacci sequence, because they're important. So here's the process of the way many organizations come up with estimates for the product backlog. What a lot of teams use is really planning poker, or user story poker, as some call it. And it's a good way of developing estimates really from a consensus basis. So how does this work? Well, the way this works is we create a card deck for each member of the project team based upon the Fibonacci sequence. So we go ahead, and in the card deck, we would have a card that says 1 on it, another card that says 2, another one with 3, and so on. And in fact, a lot of these card decks might have something less than 1, so it could be maybe a half. So you have this card deck, a half, 1, 2, 3, 5, 8, 13, and so on. And basically what you do is each member of the project team, we sit around the table, and they have a copy of the card deck. One person then goes ahead and reads the first story in the product backlog. As they read the story, team members can ask questions about it. So the product owner would be there in the room. Somebody would read the user story, and the team members would be able to ask clarifying questions. How does that really work? Well, what do you really mean by that? What do you mean by the term profile? Is that a simple profile? Is it a complex? Is there a picture of the person? Is it just a textual description? I mean, what does profile mean? So the team members can ask as many questions as they like. Eventually, what happens when the questions stop, you have to go ahead now and query the team in terms of, how long they think it's going to take, in terms of that relative estimate. So they look at the cards in front of them, and in their mind, they're thinking, okay, how does this compare against what it would take for like a home page, something I could do in a day? So what they do is they think about it, they select one of the cards, and in fact, they don't reveal that until the entire team does it. So at one time, we go ahead and all the team members reveal at the same time what their estimate was in terms of that relative index. We're really looking for consensus. So you try and go to the member of the teams with the highest and the lowest numbers first. So the person that had a 3, you'd say, well, why did you say 3 at the end of the day? Well, I mean, what leads you to believe that that's the case? You'd also go to the person that said 0. I mean, why do you think there's no effort on our part? You probably, in the particular case of that I showed you the example, you'd also probably want to go to the person that didn't have a vote at all and figure out what are they thinking? Why weren't they able to kind of arrive at a decision? So you kind of have the outliers, as they call them, chime in as to why they gave the estimate that they did. You would also ask other individuals, as well, what estimate, I mean, how did they come up with theirs? And they're free to explain at any point in time how they arrived at that estimate. I think once we've had an opportunity to talk about it and people have kind of a better understanding of the rationale, you might see some changes in the voting. So what we do is we try and vote again to try and find consensus. So we go back through the process. Everybody puts the cards in their hands again. They think about all the comments, the questions that were asked, and they try and vote again in hopes that we'll gravitate towards a common estimate. You might find sometimes that 3 people might say that it's a 1, and 3 people might say that it's a 2. Well, guess what? You want to go to the next highest in the Fibonacci scale, and that's what the Fibonacci is all about. So even though you've got kind of a split decision, half say 1, half say 2, you don't cut it in half and make it a 1.5, but you go ahead and really upsize it to 2. You go ahead and repeat this process until you've estimated all of the product backlog items. You have to remember, though, that when you're doing these votes using the card deck, each team member is thinking not only about the size, but relative complexity. And it should be contemplated in the number that they've put forward. So you try and go to the member of the teams with the highest and the lowest numbers first. So the person that had a 3, you'd say, well, why did you say 3 at the end of the day? Well, I mean, what leads you to believe that that's the case? You'd also go to the person that said 0. I mean, why do you think there's no effort on our part? You probably, in the particular case of that I showed you the example, you'd also probably want to go to the person that didn't have a vote at all and figure out what are they thinking? Why weren't they able to kind of arrive at a decision? So you kind of have the outliers, as they call them, chime in as to why they gave the estimate that they did. You would also ask other individuals, as well, what estimate, I mean, how did they come up with theirs? And they're free to explain at any point in time how they arrived at that estimate. I think once we've had an opportunity to talk about it and people have kind of a better understanding of the rationale, you might see some changes in the voting. So what we do is we try and vote again to try and find consensus. So we go back through the process. Everybody puts the cards in their hands again. They think about all the comments, the questions that were asked, and they try and vote again in hopes that we'll gravitate towards a common estimate. You might find sometimes that 3 people might say that it's a 1, and 3 people might say that it's a 2. Well, guess what? You want to go to the next highest in the Fibonacci scale, and that's what the Fibonacci is all about. So even though you've got kind of a split decision, half say 1, half say 2, you don't cut it in half and make it a 1.5, but you go ahead and really upsize it to 2. You go ahead and repeat this process until you've estimated all of the product backlog items. You have to remember, though, that when you're doing these votes using the card deck, each team member is thinking not only about the size, but relative complexity. And it should be contemplated in the number that they've put forward. Now that we have all the estimates for the requirements of the system as story points, we should be able to calculate then the cost of the system and the time it'll take to complete the project. So if we have 120 items on the product backlog, and those items add up to 412 story points, then we need to do the following. Let's assume that our sprints are going to be 2 weeks in length. Great. And also let's assume that a single developer can complete the equivalent of 20 story points in a sprint. Sprint's 2 weeks. You've got 2 points per day times 10 days. So each person can do what the equivalent is of 20 story points. So if there are 5 people on a project team, then we should be able to complete 100 story points per sprint. They actually have a unique term for it. It's called velocity of the project team. And it really is kind of a load factor. It's how many story points can this team of 5 produce over the sprint, the 2-week period of time. So we can take the 412 points for the entire product backlog. We can divide it by the velocity, which we've established as being 100. It would then take as little as, a little over 4 sprints to complete the work, so about 4.2 sprints. We always have to round up, however, when we're really talking about these calculations. So, if it's 4 sprints and a little bit, guess what? The little bit's another sprint. So we're really talking 5 sprints here. So how do we then determine the total cost and time? Well, cost really becomes the loaded hourly rate, and I'll talk about that when we get to costing. So it's really the rate for each one of these developers multiplied by 5, which is the number of sprints, times 10 weeks, which gives us the labor cost. So, one last thing we need to discuss then. We know how long it's going to take. We know what the cost is going to be. But there are other variables. What happens when new items are added to the product backlog? Guess what? The estimates are going to change. As items come off the product backlog, the estimate's going to be reduced. So you've got that issue. But you've also got a productivity issue that you need to take into consideration as well. As the project moves forward, at the end of each sprint, you're going to have to recalculate the base that was used to calculate your projected timelines. Let me give an example. So we've said right now that a story point is really equal to about 4 hours work. But what if we found out after the first sprint that the average is really not 4 hours per story point, it's actually 5. So now, in reality, if we're getting 5 for each story point, we've got to go back and recalculate all of those factors again. So the story point numbers, they won't change, but the basis for the calculation will, and it will affect the cost overall. Obviously, the sooner you find out and have to change these kind of base numbers, then the sooner you're going to be able to reproject the best figures. So, you've really got, the numbers are going to move around a little bit. And although you might have built a little bit of contingency into the numbers so far when you were doing the planning poker, well, you got to remember you still have to add an overall contingency for the project. But a little bit more when we get into the costing. So keep in mind that we leave it in story points so that if for some reason we've done a very bad job of estimating our story points, we simply have to go and change what one story point is equal to or equates to in terms of time and money, and then we can recalculate and reproject the cost and time for the system. So now that we know how long a project's going to take, by just simply looking at the product backlog, we can now create a baseline estimate that can be included in a vision document. So this is the basic math behind that. Now that we know how many user points or stories are going to be required to build a system, we now need to think about who's going to do the work and how will we get this done. One of the things that you might consider is the use of contract labor. So if you're a company, you might use contractors to complete the project. And by using contractors, it can do 2 things for you. One is that it can bring in specialized talent to do the work that you might not have, and maybe do it more efficiently than you. Or you might even want to outsource it to a foreign country somewhere as a part of getting it done. So it really is a matter of trying to shorten the delivery time as soon as possible and reduce cost wherever you can. So you may get into a situation where you will use contract or offshore labor. So you should know that there are different types of contracts, and that will impact our estimate. So what are the 3 basic types of contracts? Well, the first one is fixed price, second is time materials, and the last is time materials with a cap. So what does fixed price mean? Fixed price is where you'd actually define some specific functionality. So maybe you took a group of user stories, bundled them together, maybe there's 5 of them, and you actually had a contractor tell you how long it was going to take, and how much money it was going to cost. Then they would actually provide the time and the price, and you could ask them to do it on what's called a fixed price basis. So if they go out and estimate that it's going to take them about $8,000 to do this piece of work for you, these 5 requirements, and they will fix the price, then great, you can give them a contract and it's fixed price. If they can actually build it with less money, in less time, great. They actually get to keep the extra money that they made. But the beauty for you is that it really fixes the price. There's no variability in it. They can't come back and ask for more money later. The second type is time and materials. So that's really a situation where for every hour that the outside firm works, they will charge you on an hourly basis. So if they're charging you $85 an hour and they work for 100 hours, then you owe them $8,500. Now the only problem with time and materials is that they're really working off an estimate. So they might estimate that it's going to be $8,500 to produce something, but if it takes longer than they anticipated and it ends up being $12,000 instead of $8,500, well, that's just the way it goes. Too bad. And that's what happens on a time materials contract. You're really paying hourly for the work of the outside agency with no total in mind, just the estimate, but that's it. The third type is what we call a time materials with a cap. You will find some situations where an outside provider of services will not only work on an hourly rate, but they will also not go over a certain amount of money. So they might charge you, $65 an hour to do work, but they will not go over $10,000. So it's almost like a hybrid between a fixed price and time materials. Now, whether it's fixed price time materials or time materials with a cap, it will impact the estimate for your project. And that's why we need to talk about this today. But you also have to consider one other thing. When you make this decision about whether you want to outsource work or not, you need to think about risk, because that's an important part of this decision process. In a fixed price scenario, the contractor, the person doing the work, has all the risk. In a fixed price scenario, you're going to pay $8,500, they're going to deliver it, and guess what? If it costs them $20,000 to produce it, then too bad. They're going to have to absorb that cost. It's their loss. But if they can produce it for $1,000, we still have to pay $8,500. It's fixed price. So the nice thing about fixed price is we as a customer, we don't share in any of the risk. Our obligation is financially stated up front. It's a contractual obligation, and we will pay no more or no less for that item. In a time materials scenario, who's managing the risk? The company has all the risk. So for example, if a contractor estimates that something's going to take 100 hours and they get it done quicker, then great, the company benefits by that. So let me give you an example. This shows you a typical cost estimate for a system. We assume with this estimate that this is all going to be done internally or using time and material rates. So when we look at the left-hand side of the spreadsheet, we have to look at the various categories of information and costs. So one of the biggest costs on most projects is usually labor. So that's usually what's placed first and up front. When we have labor, we might have travel and related expenses that go along with it. So we would also include a line item for that. We may have to buy or rent some hardware. We may have to buy some software or rent some software. So we need to consider that and include those estimates as well. And I've always mentioned consistently that we want to have some type of a contingency included in our estimates, and we'll have to include that in the total cost. Eventually what we're trying to do is produce a budget total. So how much money does the customer need to set aside or earmark for our system? The return on the investment is going to be based upon this budgetary total. So in this particular case, if we round it up, $225,000, that will be the cost of the system. You're probably going to have to also justify, or really the product owner is going to have to justify how they're going to make that investment back, either reducing expenses or increasing revenue of the business, however. But that's real money, that $225,000, and it adds up quickly. You'd be surprised on any project how expensive it could be. You've also got a set of assumptions. So based upon the estimate, what types of things went into it? So let's move down, from the top to the bottom then. So let's look back at labor. In this particular estimate, we've really got a 5-person team. There's 3 developers, 1 user interface specialist, and 1 DBA. If you also look at the assumption, it talks about the makeup of the project team. And in fact, the last line says it all. The UI specialist and DBA are part-time resources available to the project team as needed. So where the first 3 developers are going to be full-time, the UI specialist and the DBA are going to be working on this system part-time. So if we know ultimately that this particular project is going to be a total of, let's say, 6 4-week sprints, then how many hours are we really talking? Well, if you take an individual, and we're really talking about 6 months here, they can typically work about 680 hours on a project. So that's at 35 hours a week that's billed to the project team. Users interface specialist, we estimated 240 hours, the DBA 60 hours. And then we actually need to look at what are the rates of the individual. If you notice at the top of the rate field, we say loaded rate. So what is a loaded rate? It's really the hourly rate of that individual plus about 30% of additional costs that covers benefits, vacation, and sick days. So if an individual, let's say an individual makes $20 an hour, and the loaded rate for that individual would be $26 an hour. So an additional 30% just to cover benefits, vacation, sick days, that kind of stuff. So 3 developers times the loaded rate is 60 times 680 hours gives you 122,000. And then you just move down, adding up the numbers. The travel and related expenses, again, that's purely an estimate. It's an educated guess based upon what you believe it'll be. A lot of times that'll be 0, but you never know. You might have to travel to conferences, other offices. You might have to go to meetings, whatever. You might need some hardware, a server. You might need some software licenses. You might need a hosting service, and that's detailed out in the estimate as well. Eventually, you're going to have a subtotal, $178,000, and then the contingency at 25% gives you $44,543, and then that gives you, if you add up 178 and the 44,000, gives you $222,000. I would then include that in the actual vision document. And at that point, the vision document should be done and complete and ready to go. You have to provide as many user stories as you can up front, even if they're large ones, so that you can provide an estimate at this stage. That might mean that you might have a 1-line requirement in the product backlog that could have an estimate of 200 story points to build. Who knows? So even though you might not fully understand all the detailed requirements for the system, you're still going to have to take a very high-level view of requirements. And in your product backlog, you're going to have to try, and even at the very highest level, figure out what the basic functionality is going to be, even though you don't have to have any of the details yet, but it still will help you create a pretty good estimate. And that's it in terms of relative estimating. And it's something that I've practiced a lot and I do believe in. It's the best tool I've found to try and estimate a system, and I'm hoping that it'll be a very valuable tool for you. You also have to remember too, if you're using outside or contract work, you're going to have to alter this cost estimate to put in those fixed amounts as well. I guess I should have mentioned that when we reviewed the chart. But again, that just makes common sense. So that's it. Good luck, and let's get those vision documents updated, and I'd sure like to see the final version. Thanks for your time.